My name is Felix Butschek. I've always had a fascination with diving, finding new places and science. With the support of Rolex and the OWUSS Scholarship Society, I've had the opportunity to reach out for the stars. This is my journey as the 2016 European Rolex Scholar, a story of diving, exploration and research. As a marine scientist and diver, the Rolex Scholarship was a dream come true, allowing me to investigate a variety of different careers. The scholarship has always had a strong diving focus, and so what better way to begin my year than with a PADI instructor course? It not only improved my diving skills, but above all, I learned how to share my passion and enthusiasm for diving with others, an experience that I found incredibly rewarding. To reach my goals in exploration and science, however, I had to step up my game and use more advanced diving technologies. In the Inspiration Rebreather, I found the perfect tool to extend my dive time. Whilst it was like learning to dive from scratch again, this journey has been tremendously rewarding. In the southwest of England, Mark Powell showed me the ropes in closed-circuit rebreather diving. By scrubbing CO2 from the exhaled breathing gas and recirculating it, rebreathers avoid releasing any bubbles. I quickly realized that this is its greatest benefit. It allows me to dive in complete silence and come a lot closer to shy aquatic life. Nothing can substitute time underwater to earn the experience necessary to survive in hostile environments, especially on a rebreather. So I headed out to the Cayman Islands and continued working on my skills. Having spent my entire career in the cold north, this was my first diving experience on a coral reef. Progressing into technical rebreather diving, I could join the National Park Service on a cultural heritage survey in Lake Mead and Lake Mojave. The Submerged Resources Center has been using rebreathers as essential tools in scientific diving for years to extend their working depth and dive time. Building my competence allowed me to be the first Rolex scholar to complete a 60-meter rebreather trimix course during the scholarship year. To do so, I traveled to the wintry St. Lawrence River, where Mike Fowler from Silent Diving taught me to take my skills into deeper and deeper water. The ocean's twilight zone is one of the last unexplored frontiers of our planet. Beyond recreational diving depths, it's often overlooked by deep diving submersibles. What a place for exploration. During my journey to become a better diver, I always wanted to use scuba for an objective rather than just for the sake of being underwater. It's always been my goal to explore and study the underwater world, especially in high latitude oceans. Few people go there put off by the cold, but whoever does ends up getting hooked, just like myself when I first went to the Arctic in 2014. When I was offered to join the Lindblad expedition to Iceland and Greenland, I jumped at the opportunity. The east coast of Greenland is a spectacular place, and there could not have been a better way of traveling there than on board the National Geographic Explorer. Lindblad provided profoundly educative approach to such remote environments and support science across different fields. When we hit our northernmost point at 74 degrees latitude, I was shocked about the early melting of sea ice, leading to a complete absence of this vital habitat. Polar bears were foraging through bird cliffs hunting for eggs rather than seals. This hungry polar bear family was a stark contrast to the bears I had filmed only a year earlier in the Norwegian Arctic. In this moment, I was reminded of the devastating effect human-driven climate change has on this beautiful environment. Polar research, though, gives us some grounds for hope. The guest scientist on board discovered the glacial mud discharged from ice sheets increases marine and terrestrial productivity. That's why the boreal forest corresponds so well to the extent of the last glaciation. The cryosphere is far more linked to life and biological processes than we had ever thought. Such advances in science may soon help us combat desertification and the loss of biodiversity on our planet. For me, as a budding marine scientist with an interest in climate research, this is an encouraging thought. True exploration, the discovery of new territory, is near impossible on land, even on the northernmost Arctic islands. So I ventured underground. In autumn, Lenny and Claire Vogel welcomed me to their dive center in Tulum, Mexico. There, I gained access to the liquid underworld under the instruction of Ian France and Sami Pakarinen. When I first entered the cenotes, I was in awe. Diving a closed-circuit rebreather, I learned how to navigate safely through these underwater caves. I also joined Lamar Hayes in Florida for an open-circuit cave class. With more and more tools at my disposal, I got to explore 18 different cave systems in 5 countries. While this may not have been exploration in its original sense of finding new ground, entering a system new to you as a novice cave diver is like discovering it for yourself. Let me try and explain my fascination with the subterranean world. Venturing underground is like a journey through geological history. These caves are ancient seabed laid down over millions of years and featuring a staggering amount of fossilized life. The marine life that found its last resting place in the rocks of the northern Florida Springs now gives rise to new life. We rely on the spring water for drinking, utilities and agriculture. The way I see it, just like our ocean, this is an environment to be treasured and protected. Christina Senato introduced me to the Bahamas, where the caves are geological archives of the past. During periods of glaciation, when the sea level was lower, the caves were largely dry. Filtration of water into the caves gave rise to amazing formations called stalagmites and stalactites. These are more than just beautiful. The calcium carbonate that crystallized out is a climatic record and a huge resource for science. Eventually I managed to combine my passion for exploration, diving and cold, remote environments by joining Oscar Svensson, the 2012 European Rolex scholar on the Bjurelven expedition. This is an ongoing cave exploration project in northern Sweden. Underneath a thick layer of ice, the water is just above the freezing point.
Cold?
What?
Cold?
We dived to about 200 meters into the frozen ground. In 2012, this was the furthest anyone had been. Today, the Bjurelven expedition team has explored more than 2,000 meters of cave passage. I learned to use location-finding magnetic transmitters and receivers in order to map these caves precisely.
Got to walk up here. We had the third chamber. So next chamber is other side of this little lake here. Here's the zero. So now you can stand here.
It was a tremendous experience to dive there as well as film in Plural, Norway's largest underwater cave just above the Arctic Circle. conditions and various equipment issues threw countless challenges at us, but in overcoming difficulties and going to the edge of my comfort zone, I found myself in the best learning environment and discovered my passion for exploration. Exploring new parts of our planet is the first step in understanding these remote environments. Yet my curiosity has always pushed me towards science. During my scholarship year, I had the opportunity to join scientific expeditions to two of the most remote areas on Earth. In January, I joined Vreni Häusermann, the Rolex Award laureate for exploration, on a cold water coral research project in Chile and Patagonia. There, the coral Desmophyllum dianthus suffered mass mortality in 2012, wiping out its entire population in Koma Fjord. Ever since, scientists have studied the coral's recovery under the challenging conditions at the edge of their range. The survival of these corals is fascinating because they usually live much deeper and in higher pH environments. We spent hours recording the fjord's species assemblage for ecological long-term studies and analyzing seawater chemistry in the lab. The Falkland Islands are another remote and unexplored archipelago in the southern hemisphere. There, I was modeling one of the most complex habitats, kelp holdfasts, using 3D photogrammetry. With the limited time we were able to spend underwater, we tried to collect as much data as possible. I cannot wait to return to the Falklands and Chile and advance our understanding of these remote areas using rebreather technology. The Rolex scholarship confirmed that the track that I've been following for years was the right one and a challenge to excel at the same time. Through my adventures and a host of supporters who have influenced me, I found my greatest strengths, interests, and how these will shape my future. The Our World Underwater Scholarship Society and Rolex have enabled me to accelerate my diving and gather skills that would otherwise have taken years, maybe decades of learning. I've always thought of diving as a toolkit to solve difficult situations underwater and approach challenging environments. I set out to expand my toolkit, and the scholarship allowed me to build an entire workshop. In doing this, I found a deep-seated passion for cold water exploration and benthic ecology, which has laid the foundation for an exciting career in marine science.